The idea is not to provoke public opinion, but rather to make things simple to the public opinion by telling them science in the way you talk about daily life things. So in that particular talk in TEDx, this was about stealing electrons, and now the public may not understand what an electron is, or may have very vague understanding, but once you compare it to stealing rather than attracting electrons or transferring charge, so instead if you talk like stealing, this is something that the public unfortunately knows what this is, because there are thieves all over, and therefore, this is just the way to communicate science. And communicating science is definitely the public mission of science that must be done to avoid the very broadening gap between public understanding and science front to close down. So that we want to narrow down this gap, because it's unadmissibly large at these days. So that the public does not understand what scientists say. On the other hand, they tend somehow to believe scientists, and therefore there is that's a perfect way to exploit public by telling them things on a mass scale that are not true and manipulate the whole societies. Therefore, communicating science for me is an essential part of my job. It simplifies my research, because there is this old saying, if you cannot explain your science to your 5-year-old kid, then you do not understand it either. And therefore, by making things simple, you can think simple in your own scientific mind, and simplicity is the key ingredient of important scientific discoveries. I have mixed feelings, basically, because in the system that was used in the past, we as scientists were publishing our results in the journals that partly were commercial editors, publishing houses, partly like ACS or RSC or GDCH, they were owned by chemical societies. These were two very different things, in fact. If you concentrate solely on those commercial publishing houses, then put yourself into a scientist's shoes. Public is paying huge money in grants to a scientist to do research. This research is peer-reviewed by his colleagues for free. That's a professional peer review. At the end of the day, he is publishing his article that was paid by the society in the journal, and he as a author can have access to his paper only, and he's not even allowed to distribute this. Everyone else in the world must buy it. This is certainly unfair. This shouldn't be like this. This were public money. That's why the one subtlety here is that even if you are a very, very big publisher and powerful commercial publisher, there is this clause that if you, for example, work for the US government, they can publish, let's say, free of charge in this journal. So they make exception. So again, this is not an equal treatment of scientists. But the stronger ones can influence the publishing houses. Now, open access. Open access is not a bad idea in principle, but what we actually experience now, and everyone I think will admit that, is a literal flood of open access that has very little quality, so that even in some journals, they are not checking the novelty of the idea, but they are solely checking whether this is technically correct. Even if you write an article telling, this is how a wheel works, I invented a wheel, they will say this is technically correct, it can go on, and let the community judge the quality of this research. So this is not the best idea either, because in this way the quality of peer review is much reduced, because this open access is not driven by scientific quality but by money. So they want the money to be paid to ensure open access. And I don't like both systems. I think something else is needed, or maybe, yeah, in general, this is well known that, let's say, ACS or RSC, as publishers, the chemical societies, they are way more efficient, they charge much less than the commercial ones. And I think this should possibly be the best way to do it still. If you want to speak very broadly, there are some extremely vividly developing fields of science. Let's say one is quantum information technologies. Now this can revolutionize science completely. It will revolutionize the way we store data, we read the data, we pay in the banks, we ensure security of our information transfer everywhere. This can be a revolution. Another revolution, which is certainly at the door somewhere, is related to biochemistry. So that, as you know, 2 years ago, Nobel Prize in Chemistry was awarded to researchers who showed that it's possible to modify DNA inside the living cell. Now, that's something revolutionary. But both these fields, although I am not involved in them, will definitely have the same aspect as every other scientific discovery. Namely, they can be used for good and for bad purposes. And there are always many questions about how this is used, by whom this is used, how people are affected backdoor, you know. Well, there can also be another revolution. As you know, really few years ago, we saw the first room temperature superconductor. So some superconductor that does not require cooling for its work. Unfortunately, however, it's very beautiful basic research, this superconductor is enclosed in extremely small volume. And extremely huge pressure is needed to keep it like this. If you release the pressure or if you increase the volume, everything will go away. Therefore, the effort of people is directed towards generating room temperature, ambient pressure superconductor. And that is something I am very much for. And this is my piece of research, and like many other fields, it can revolutionize our daily life. Imagine if you could generate, using standard techniques for growing of semiconductor junctions, if you could generate special junctions that will superconduct, then maybe it's not good for transferring electric current in large quantities, but it is certainly good to build new generation supercomputers. These supercomputers can be by the factor of at least 10,000 faster than those used today. Imagine the revolution that will come with it. Now, again, it will have good sides and bad consequences for humanity, but this is just inherent part of science. I can tell you two things here. One, that I really had an excellent teacher, because Roald Hoffmann, who was my mentor, is not only an excellent scientist, he is the top world popularizer of science, popularizer, I should say. So if you go solely to Scientific American, which is a scientific popular thing, you will discover hundreds of articles he wrote about popularization of science. And they are indeed written, with this human touch, with this with this spirit that helps other people to understand it. He is a master of simplicity. So on one hand, I had excellent teacher. On the other hand, I can tell you that it was always inside me. It just needed to be developed, so that I take probably most, let's say, pleasure in teaching humanities, because they have so different way of thinking that they raise the most interesting questions. Something that would seemingly be obvious to a science kid, for them it's not obvious, and then you need to explain them from the very bottom of the things. And then you tell them there is no real bottom. At some point it happens. And with humanities you reach that point very fast. Because with students of technical topics, they think, okay, so this is an established truth, and then we go on with this. But if you scratch this established truth, you will shortly discover it's not true indeed. There is still another bottom, and yet another one. That is how science approaches understanding of what the truth is. We all search for the truth. So the truth we can approximate by models, we can approach it somehow, tangentially in some ways, but we cannot get there. So criticism is the most important part of our job. There is nothing like an established science. We can break it at every possible point.